Be a short podcast on how to actually deal with pH. So just as a general reminder, pH is defined as the negative log of the hydrogen ion concentration. Sometimes it's also defined as the negative log of the hydronium ion concentration. And so just keep in mind these two things are both the same. So as long as you have the numbers for this, you're good. Now, what makes it difficult for AP chemistry? Well, you're either going to have a strong acid or you're going to have a weak acid. And if it's a strong acid, then whatever the molarity of that strong acid is going to be the molarity of the hydrogen ion concentration. Because by definition, a strong acid strongly dissociates. So if I have HCl and I put this in solution, and let's say I have 3 molar of this, then all 3 molars of it will become H plus and Cl minus. And so if the concentration of the HCl is 3 molars, then the H plus concentration will also be 3 molar. And that's assuming it's a strong acid. And so if we look at some of the problems that are listed on here, it says, what is the pH of this? Well, that's easy. I don't think I need to help you on that one. Let's look at the next one. For number 2, it's asking us to find what is the H plus concentration. So this one's a little bit trickier. This is requiring knowledge of logarithms, and of course I know you know logarithms. So if I wanted to solve this one, all I need to do is actually remind myself that log, of course, is log base 10. And if I say log base 10 of the H plus concentration is equal to pH, and I'm trying to find the H plus, then I need to move the negative first. Log base 10 of H plus is going to then equal the negative pH. And of course, the idea of this is that the question is 10 to what power is going to give me this number. So therefore, if I want to find H plus, then I need to put 10 to what power. In this case, it's going to be pH. So if you ever want to just find the H plus concentration given the pH, all you got to do is 10 raised to that power. Okay? So 1 and 2 I think is pretty straightforward. I'll let you try that on your own. However, if I go to the next one, sorry, I escaped there, and click on the next question here. Number 3 is a little bit trickier because here we have scenarios now where you start dealing with weak acids or the conjugate base of a weak acid, and you've got to be able to know what to actually do with this. So hopefully you have this memorized. You hopefully have that down here okay, because I'm about to erase it. So going to this table, so let me open this table. One of the things that you're supposed to identify is that this salt right here, and the reason why it's a salt because it says KNO2. If you have this salt, what you want to do is treat it as K plus and NO2 minus in solution, because the salt is a strong electrolyte because K plus is highly soluble and it will separate no matter what, because this is part of the group 1 elements. All group 1 elements will always separate. So then if I put NO2 minus in solution and I look at the chart that's on the other page, I can find NO2. Oops, sorry, just writing on there. Let me just kind of scan down here. NO2, where is NO2? Sorry, there it is right here. So NO2 is right here. NO2 ion will act like a base. It even tells you. So it's going to act like a base, which means that NO2 will find a water because it's actually a conjugate base of a weak acid, and it will produce HNO2 plus OH minus. So in this context, you get this, and of course you need to actually write the Kb for this, and they give us the Kb for the nitrite ion at 2.2 times 10 to the minus 11. So that's going to be an important number. And so all I have to do now is go back to the other screen. And so knowing this 2.2 times 10 to the minus 2 minus, I have to set up an ice table. And for this ice table, what you want to think of is that this guy right here, in the beginning, I actually have a 1.19 molar of this stuff because that is the molarity of the potassium nitrite solution. And so since it's going to, just like in a strong acid, since it disassociates completely, that's going to be my initial concentration. And my water, of course, produces nothing. HNO2, of course, has 0 in the beginning, and that has 0. The change, of course, will be a minus x in this one. Since everything is a 1-to-1-to-1 ratio, this will be a plus x and a plus x. And then my equilibrium expression will be 1.19x, x and x. And the KEQ for this, the KB for this will be HNO2 times OH minus, all divided by NO2 minus. And so, of course, we're ignoring the H2O. You plug in all these numbers in here and you get x squared all over 1.19x. So, minus x. I forgot my minus x on here. Minus x, minus x. So, from here, of course, we set this equal to my KB. Those two are equal. You solve. And you could even assume for this particular problem, because since it's 10 to the minus 11, 1.19 minus x is going to be so small that this is going to be approximately equal to 1.19. And the reason we can use this is because that's 10 to the minus 11, and for good approximations, basically I can just say x squared all over 1.19 is going to equal 2.2 times 10 to the minus 11. Solve for x, take the square root. That'll, of course, give me my OH concentration. And if I know my OH concentration, then I can then use the fact that pH plus POH is equal to 14 and find POH by using the negative log of the OH concentration. So once you know this, you can plug that in, solve for pH, and then you're done. So let's look at other ones. Let's see if there's anything else we have here. Let's escape there. Let's see. Number 4 is pretty much the same thing. This time NH4 is going to act like an acid. Number 5 is a dilution problem. This is a strong acid. So if you know the molarity and volume of the first one, using a green pen, hopefully you can see this, M1V1 will equal M2V2. And if I know the new molarity after I dilute it to a total volume of 250, then I can actually, if I know the molarity, strong acid, basically what we talked about in number 1. And let's see, number 6 is a little tricky. I'll let you think about that one. Ask me a question in class about that one if you have any questions. And then number 7, same thing again. I'll let you ask me for help on that one directly in class. I want you to think about it, see if you can come up with an idea, and then I, of course, can make another podcast on that. But that's it for now. Hopefully that helps, at least for